Okay, let me make a revision of what we did in our last class. We talked about the probability, okay, and in probability we defined the very basic terminology. One was the experiment. An experiment is the process of observation, okay, and the next one is the sample point, and sample point is the basic outcome of the experiment. So once we have the experiment, we get the different results, we get the different outcomes, okay, and those outcomes or the basic results are called the sample points. We can also use the Venn diagram. Venn diagram is the graphical representation for the sample point, okay. We have the experiment, we do experiment, we get the results, and we use a graphical representation which we call the Venn diagram for the sample points. The next we had a sample space, and sample space is the collection of all its sample points. So you collect every sample points in a set notation, that is your sample space, okay. And we use you can just use any, but in general we use S to represent our sample space, okay. The next, yes, probability, and the probability is a number, okay, between 0 and 1. Probability can be equals to 0, probability can be equals to 1, and it takes a number, any number between 0 and 1. And we measure the likelihood that outcome, okay, will occur when the experiment is performed. That is about the probability. So there is the two basic rule for the probability of the for the sample point. One is all sample point probabilities must lie between 0 and 1. So this is the definition of probability. So the probability for every sample point, it has to be equals to 0, okay, equals to 1, or in between 0 and 1. The next second rule is that the probabilities of all the sample points within a sample space must sum to 1, okay. So we have this sample space, for example, so we have this sample space. Now the sum of the probabilities of each sample point, so we find the probability of this sample point, we find the probability of this sample point, okay, we find the probability of each sample point, and the sum of these probabilities must be equals to 1. That is the second rule, okay. So the next we had an event. An event is the specific collection of sample points. So we are interested in certain sample points, okay, not every sample points, and those collection, the specific collection of the sample point is the event. So we had this example, yes. So this is all we had in our last class, okay. Do you have any question up to here? Now, so once we have the event, now how do we find the probability of the event? Now the probability of event A, okay, the probability of event A is calculated by summing the probabilities of sample points in the sample space for A. So here, so let me take a sample space. So for example, our sample space S is 1, 2, 3, 4, 5, 6. So let's consider this is our sample space, okay, and let's define an event, and our event A is even number, okay. For example, our event A is, we are interested in knowing the probability of even numbers. Now if A event is the collection of even number, what are the sample points for this event A? What will be the sample points for this event A? Our event A is the collection of the even numbers, so the sample points should be 2, 4, 6, right? So these are the sample point for our event A. Now the probability of this event A, so that's what we want. We want to know the probability of our event A. So this probability of event A is the sum of probabilities of the sample points in the event A. Now, So this probability of event A is the sum of probability of sample point in the event A. So this is the event A. We find the probability of each sample point of this event A and we add those probability and we get the probability of event A. So this is probability of getting 2 plus probability of getting 4 plus probability of getting 6. Okay. Now what is the probability of having phase 2 when we roll a dice is 1/6, right? So we have 1/6. Similarly, the probability of getting 4 when we roll a dice, that is 1/6, and the probability of having 6 when we roll a dice, that is also 1/6, and we have 3/6, and this is 1/2. So 1/2 is the probability of our event A. So whenever we are interested in finding the probability of an event, we list a sample point in that specific event. Okay, we find the probability of each sample point on that event and we find a sum of those probabilities. That gives us the probability of the event. Okay, so here are the basic steps to find the probability of an event. At first, we define the experiment. Okay. Once we have the experiment, we are interested in the outcomes or the results, and those results or outcomes are the sample points. So we list sample points. First, you define the experiment, you list the sample point. Okay. Next, we assign probabilities to the sample points. Like here, for example, so in this example, what is our experiment? Rolling a dice, right? So rolling a dice is a experiment here. Okay, and what are our sample points for this? Sample points is 1, 2, 3, 4, 5, 6. So these are the sample points. So we list the sample points. Okay, then we assign probabilities to the sample points. Now, what is the probability of getting each sample points? P of 1 equals to P of 2 equals to P of 3 equals to probability of getting 4, probability of getting 5, probability of getting 6. All these is equals to 1/6, right? It's the same probability. So we assign probabilities for each sample points. That's our third step. Okay, and after that, we determine the collection of sample point contained in the event. Our event of interest is even numbers. So we collect the sample points, and those sample points are 2, 4, 6. So we collect the sample points contained in the event of the interest. So this is our next step. And at the end, we sum the sample point probabilities to get the probability of event. And this is our last step. So this is what we did here. You define the experiment, you collect your outcomes, you collect your sample points, you give the probabilities for each sample point. Okay, and the next we collect the sample point in the event of interest, and at the end we find the sum of probabilities of the sample point on that event. So these are the basic steps for finding the probability of an event. Okay, now let's do an example. So here we have this example. Do you have any question here up to here? Okay, so here we have an example. So let me scroll down. Okay, now let's go through this. So here, the American Association of Marriage and Family Therapy is a group of professional therapists and family practitioners that treats many of the nation's couples and families. The AAMFT released the findings of a study that tracked the post-divorce history of 100 pairs of former spouses with children. Each divorced couple was classified into one of 4 groups. Okay, so we have 4 groups: Perfect Pals PP, Cooperative Colleagues CC, Angry Associates AA, and Fairy Foes FF. The proportions classified into each group are shown in the table. Okay. Now here we have this table. So we have the proportion 0.12 for perfect poles, okay, PP, 0.38 for cooperative colleagues. Now there is a definition given, okay, like what is perfect poles. So they have defined joint custody parents who get along well. So that's the perfect poles. Cooperative colleagues, they are the occasional conflict likely to be remarried. Angry associates, these are the cooperate on children related issue only, conflicting otherwise. Fiery foes, communicate only through children hostile towards each other. So we have the proportion for each of these group. Now the very first thing here, we are asked to define the experiment here. Now what is the experiment done here in this case here? So what is the experiment for us? So what this AAMFT did, so what they are doing, so they released the findings of a study that tracked the post-divorce history of 100 pairs of former spouse with children. Each divorced couple was classified into one of 4 groups. So what do you think? So what is the experiment here? So they have 100 pairs of former spouses with children. And what did AAMFT did to 100 pairs of former spouses? Can you just repeat that?
They're finding the study that tracked the post-divorce history.
Yes, or the other way is that they are classifying this 100 pair of former spouse, right? So classifying is an experiment here, okay? So our experiment is classifying the randomly selected couple. So that's the experiment here, okay? So classifying randomly selected couples, okay? So this is an experiment classifying the 100 pair of couples, spouses with children, okay? So this is the experiment. Now, once they classify, so what are the results or what are the outcomes they had? So what are the results here? So once they classify this 100 pair of former spouse, so what are the results? Or what are the groups they have for this 100 pair of former spouse?
Perfect pals, cooperative colleagues, angry associates, fiery foes.
Yes, and these are the sample points. Okay, so our sample point is, so let me use PP, or I can just write the sample space, collecting all sample points. Okay, so let me write S equals to PP, perfect poles. Okay, we have CC, AA, and FF. So these are the outcomes. These are the results of classifying randomly selected couples. Okay, and these results are the sample points. You collect sample points, we get sample space. Okay, the next we assign probabilities to each sample points. Now, what is the probability that the couple will be PP? Is it given to us or do we need to find by ourselves? It's given, the proportion is given to us, okay, and it's the probability. So the probability of PP, okay, so let me, so the third step is assigning probabilities to the sample points. So we have 4 of these sample points. So probability of the couple to be PP is 0.12. It is given to us here. Similarly, the probability that a couple is CC, this is 0.38. Okay, the probability that a couple is AA is 0.25, and the probability that a couple is FF is 0.25. So this is our third step. So we assign the probabilities for each sample points. Do you have a question up to here? Okay, now once we assign the probabilities to each sample point, our next, so we are asked a question here. What is the probability that the former spouse are FF? Can you tell me that from the table, or we already have that answer? So we are asked probability that the former spouse are FF. And what is this probability for us? It is given to us, which is 0.25. So there is nothing we need to calculate. It's 0.25. Okay. Now, can you do number D? So in number D, you are asked to find the probability that the former spouse have at least some conflicts in their relationships. So you are asked to find the probability that the former spouse have at least some conflicts in their relationship. Now, in what sample points are we interested here? Are we interested in all of the 4 sample points or one? So you're gonna make a list of sample point for this event. Okay, so your event is we are looking for the former spouse that have at least some conflicts in their relationship. So you make a list of sample point in this specific event, and once you have that list of sample points, you add the probabilities of those sample points, you get the probability. Okay, can you try this? So what is the probability that the form? Okay, at first make a list of the sample points. So you have the 4 options, and out of 4, so which group has at least some conflicts in their relationship? So you are writing the groups, okay, you are listing the groups that have at least some conflicts in their relationship. You have 4 groups. Out of these 4 groups, you're gonna make a list of group that has at least some conflicts in their relationship. So let me call that event is A. Can you tell me what are those groups? CCAAFF. These 3 groups have at least some conflicts, and you can find this from their definition. Okay, like here. So our CC, they have occasional conflict. Okay, so we are interested in the former spouse that have at least some conflicts. So they do have some conflict. Angry associates, they do have conflicting otherwise. Okay, and FF also, they have hostile towards each other. So communicate only through children. So they also have conflicts in this group. But PP, there is nothing about the conflict. So these three are the sample points, okay, which have at least some conflicts in their relationship. And we are interested in finding the probability of this event A. So we are asked to find P of A. So this is unknown to us. Now how do we find P of A? P of A is sum of probability of these sample points. So probability of CC plus probability of AA plus probability of FF. So you are adding the probability of each sample point in the event okay, our event is A, and this is we already know this, so we make a substitution. So P of CC is 0.38 plus P of AA 0.25 plus P of FF is 0.25, and this is 0.88. So 88%, okay, or 0.88 is the probability that the former spouse have at least some conflicts in their relationships. Okay, so these are the very basic steps. You must know the experiment. Once you know the experiment, you're gonna find out the results, outcomes, which are the sample points. You assign probability for each sample point, then you find the probability of the event. Okay. Let me know if you have question here in this example. Can you all find the probability of any event now? Okay, before we go to the next one, let's do one example. Okay, so this is from our book. So I want you can work in a group, okay, if you would like, or if you can do by yours. Okay, number 11. Okay, can you read these? Okay, let me try. Maybe just give me a second. Takes. This is still blur. Okay, let me read this for you. Or let me write down here. So this is not helping you here. So here, so the sample space for an experiment contains 5 sample points. Okay. Okay, so your event A is given as, so your event A, okay, your sample space S is, okay, 1 2 3 4 5. Okay, 1 2 3 4 5. So this is the sample space. Okay, and there is an event A, and the event A is either 1 2 or 3. Okay, this is your event A. Event B is either 1 3. Okay, we haven't used or 8, so let me use comma here. Okay, we'll be talking about this or, and 5. And we have event C, and event C is 4 does not occur. Okay, the probability for each sample point is given as, so we have sample point, this is going to be a table, and we have probabilities. So for sample point 1, the probability is 0.05. For sample point 2, the probability is 0.20. For 3, the probability is 0.3. For 4, the probability is 0.3. And for 5, the probability is 0.15. Now you need to find the probability of event A, okay, probability of event B, and probability of event C. So I want you to find P of A, P of B, and P of C. So find these 3. Find the probability of event A, event B, and event C. And if you need help, let me know. Okay, your sample space is 1 2 3 4 5. Okay, so
Are we just adding, the number of choices for probability?
that's right. So for event A, you're gonna add the probability of it 1 2 3, and the probability is from the table. Okay.
Thank you.
So what you can do is that you can just do P of A equals to 0.55, okay, or P of B equals to. So 0.55 is some probability, so you are not writing. So if you write this, you also need to find the probability of getting 0.55. So the probability of event A is 0.55. So if you have something different or 55%, okay. Probability of event B is 50% and the probability of C is 70% or 0.7. So everything is given on this table, you just need to add these numbers. Okay. So here, so our P of A. So A has sample points 1, 2, 3. So you are adding the probability of 1, 2, 3. So probability of 1 is 0.05, probability of 2 is 0.20, and probability of getting 3 is 0.3. So you add these three numbers, you get P of A. 0.05 plus 0.2 plus 0.3. And this is 0.55. For probability of B, event B, so event B has a sample point 1, 3, 5. So you are adding the probability of 1, which is 0.05, 3, which is 0.3, and the probability of 5 is 0.15. So you are adding these three numbers. So 0.05 plus 0.3 plus 0.15. This is 0.5. Now the last one, the probability of event C. So C, okay, now C has 4 does not occur means. So what are the sample point here? 1, 2, 3, and 5, right? So 1, 2, 3, 5. So you are excluding 4. So 1, 2, 3, 5 are the sample points, and you are adding the probability of these sample points. So you are adding 0.05, 0.20, 0.3, 0.15. So this is 0.05 plus 0.20 plus 0.3 plus 0.15. Is it 0.7? Okay, so these are the probabilities. Okay, do you have a question on this example? All right, now, so let me, okay, so how many of you are here today? 3, 4, 7, 9, 16. Okay. Now, so we are 16 here. So if you want to make a group of 3 out of these 16, how many groups can you make?
5.
So
Out of 16, you can make 5 groups of 3.
okay, now here, let me just rephrase it. So we are 16 here, and you wanna select 3 students from out of 16. In how many ways you can pick those 3 students out of 16? So you are picking 3 students out of 16. Now I want you to tell me in how many ways you can pick that group with 3 students. For example, so I can pick these 3 students as one group, right? I can pick these 3 as a second group, or I can pick those 2 and her. So how many ways? Like in how many ways we can have that group here? Is it still gonna be 5 or more than 5? It's gonna be more than 5, right? Okay, let me, so, okay, before that, so if you have okay, so in how many ways you can arrange these 3 letters? Okay, let's try. So you can have A, B, C, this is the one way, right? So B, A, C, What is the other? CAB, BCA. Any more? ACB, ACB, CBA. 1, 2, 3, 4, 5, 6. Do we have any more? Is there any? Maybe.
Do you just square the amount?
I'm sorry?
For these problems, you just square the amount?
That's not going to help us here. Now here we have a formula. We have a combination rule. Okay, that's the rule. It's going to help us to find this number. Okay, and we'll apply it over here too. Okay, now we use this method. Okay, to find the number of sample points for an experiment. Okay, if we have like a sample of 1,000 people, or like if we have a big sample, okay, if our experiment has a big number of data set, then we use this combination rule to find the sample points. Okay, now here let me use a different notation. So I have n, so let me call this p. Okay, suppose a sample of p elements is to be drawn without replacement from a set of n elements. So for example, we have a set of n elements. Okay, n is any number. We have big n. Okay, we have these n elements, and out of n elements, we need to pick p elements. Like, so we have 16 here, right? So 16 is our n, and we are picking 3 students. So 3 is p. So we have n number of elements in a set. Okay, and out of n elements, we are picking p elements. Then the number of different sample possible is denoted by, okay, now this is how we denote. So this is p. Okay, I'm using p for n here. So the number of possible sample is np here, and this is equals to, now this is equals to, we have n. Now have you seen this sign? Do you know what do we call? So this is, okay, let me rewrite this. What do we call this? N factorial. Okay, and we'll define what is this n factorial. So the number of the possible sample is n factorial divided by p factorial, okay, times n minus p factorial. So this is n factorial. Okay, this is how we read. So this is the formula that help us to give us the different possible samples. Now this n factorial, okay, so this n factorial, sorry, this is not the right one. So the n factorial is n time n minus 1, n minus 2, n minus 3 times all the way up to 3 times 2 times 1. Now let me do an example, then you will be clear here. So let me erase this here. For example, if we are interested in finding the 5 factorial, so for example, if we want to find what is 5 factorial equals to, so what we do, so our n is our 5, so we have 5 times 5 minus 1, okay, which is 4, right? Then 5 minus 2, which is 3, times 5 minus 3, 5 minus 4, okay. Do we have the difference equals to 1? So 5 minus 4 is 1, right? 5 minus 3 is 2. 5 minus 2 is 3. Okay, then we have this. Now this is 5 times 4 times 3 times 2 times 1. And what is this product equals to? 5 times 4, 20, times 3 is 60, times 2, 120. So 5 factorial is 120. So you are multiplying, okay, the number all the way up to 1. You are going in the descending order, okay. Like for example, if you want to find 3 factorial, you are multiplying 3 all the way up to 1. So this is 6. If you want to know 4 factorial, you are starting from 4 and you are multiplying all the way up to 1. 4, 3, 2, 1, which is 24. Okay. Similarly, 10 factorial. What will be 10 factorial? So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you are multiplying up to 1. And what this give us? Can anyone help me here? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or you might have that factorial sign on your calculator too, okay? You can use that.
3 million.
How much?
3,628,000.
That's a big number, okay, some big number here. But yeah, you can find this factorial sign on your calculator, okay? So you try the number, hit the factorial sign, and it gives you the final answer. And this is how we define the factorial. Okay, now let's do an example here. Now let's do the one that we had earlier. Now let's see in how many ways we can pick 3 students out of 16. Okay, so in that example, what is our n? N is the so our 16 is the n. Okay, so our n is 16. So we are 16 here all together, and we want to pick any 3 students. Okay, our p is 3. And we want to find the possible ways of selecting 3 students from this class. Now let's use this formula. So we represent by NP. So this is how we represent. So we substitute 16, 3, right? Now our formula is 16 factorial. N factorial is 16 factorial divided by P factorial. P is our 3. So 3 factorial time n minus p factorial. So our n is 16 minus 3 factorial. So we have 16 students all together, and we want to know in how many ways we can pick 3 students out of this 16. Now let's simplify this. Okay, so this is, so we have 16 factorial. This is 3 factorial. 16 minus 3 is 13 factorial. Now, so what is 16 factorial? 16 factorial is 16 times 15 times 14 times, can I do 13 factorial? So what is 16 factorial is? 16 times 15 times 14 times 13 times 12 times 11 times all the way up to 1, right? So I call this as a 13 factorial here, okay? And the reason here is that we can cancel that 13 factorial. So this is gone. Okay, now let's find what is 3 factorial. So 3 factorial is 3 times 2 times 1. Now we can simplify. 3 times 5 is 15. 2 times 8 is 16. So 8 times 5 times 14. What is that equals to? 8 times 5 times 14. And this is equals to 8 times 5, 46. Is it 560? Okay. So we can select, we can have a group of that 3 students we can have that group in 560 different ways. Do you have a question here like how I got from here to here? So 16 factorial is so you are multiplying number starting from 16 all the way up to 1, right? Now our 13 factorial, your 13 what is 13 factorial? 13 factorial is from 13 times 12 times 11 times 10 times all the way up to 1. Okay, now I just call these numbers that we have over here as a 13 factorial so that we can cancel with our denominator 13 factorial here. Okay, so I'm making my calculation simpler, or you can use calculator. I think you should be able to find this factorial sign. Okay, you can use the calculator and get this number. So we can select 3 students in 560 ways. Okay. Do you have a question? We have pretty similar example here. I'm going to the next example here. So here, suppose a movie reviewer for a newspaper reviews 5 movies each month. The month the reviewer has 20 new movies from which to make a selection. How many different samples of 5 movies can be selected from 20? Can we do this? Now, so the reviewer, he reviews 5 movies each month, and the option he has is he got the 20 new movies, and he need to select 5 movies out of that 20. Now, in how many ways that he select 5 movies out of 20? So that's what we need to find. So you have the 20 movies, and you need to select 5 movies out of 20. And your target is finding the number of ways you can select 5 movies from that 20. Now, what is our n here? 20. Okay. What is our p? 5. Now you substitute these numbers in our formula. Okay, here. So we have 20 total movies, and we are selecting 5. So this is 20 factorial divided by 5 factorial times 20 minus 5 factorial. So this is 20 factorial is 20 times 19 times 18 times 17 times 16 times, let me do 15 factorial. Okay, and you will know the reason here. So this is 5 factorial. 20 minus 5 is 15 factorial. Now you can cancel this 15 factorial and this 15 factorial. If you want to write up to 1, yeah, you can go ahead and write. Okay. The next here we have 20 times 19 times 18 times 17 times 16. And 5 factorial is 5 times 4 times 3 times 2 times 1. Now let's simplify. So 5 times 4 is 20, 4 times 4 is 16, 3 times 6 is 18, 2 times 2 is 4. So we have 2 times 19 times 6 times 17 times 4. So we have 15,504 different ways of selecting 5 movies from 20 sample. So we can select in 15,504 ways. So this is the number of ways we can select 5 movies from 20. Okay, can you find what is this equals to? Can you just find the possible ways of selecting 2 from 7? Okay. Find the possible ways of selecting 2 from 7. Okay. So this is your n and this is your p. And And so once you have the final answer for this, you are free. You can leave the class. Yes. 21. Okay. Is there more you have? 21. Oh, okay. Everything is under calculator. Okay. 21 is your final answer. If you have 21, get. And this is all for today, okay?